I'm Anil Kumar, and in this video we are going to discuss domain and range of reciprocal function, right? So let me define the reciprocal function first. It is f of x equals to 1 over x. So if I sketch this function, it will look like kind of like this. Let me sketch it here once. All my sketches are going to be rough, but they'll give you an idea of how we should be doing it, right? So that is the reciprocal function for us. You could actually make a table of values to sketch this function. So let me make a small table of values to start with. So if I write different values of x, good values of x to be taken will be, let us say we take minus 4, we can take minus 2, minus 1, 0, 1, 2, and 4, let us say, right? Now, if I do 1 over this number, so then I get minus 1 over 4. This I get minus half. This I get minus 1. And 1 over 0 does not exist, right? So that gives me this vertical asymptote. This does not exist, gives me the vertical asymptote. Perfect. For 1, we get 1. For 2, we get half. And for 4, we get 1 over 4. So these are the numbers which we get if we take these numbers. Now it is very interesting to note that if you take numbers in between plus and minus 1, then you get very high numbers. For example, so let me make another table here just to expand this portion, right? So let me expand this portion. So the idea here is to view what happens in this portion, right? So let me take more numbers here. So I'm taking numbers which are between 0 and minus 1. So let us say we take a number which is very close to 0. This is 0 for us. Let us say we take a number which is half. Half. So half reciprocal will be 2. Do you get an idea? If I take a number 1/4, the reciprocal will be 4, right? On the other side, if I take minus 1 over 4, then the reciprocal will be minus 4. And minus half will give me minus 2. So these numbers suggest that as we go closer and closer to 0, the values become higher and higher, right? So if these numbers are 1, 1, right? So these are numbers are 1, 1. In that case, or minus 1, minus 1, we'll have this kind of a figure. So if we go very close to 0, for example, if we take a number here, which is, let us say 1 over 100, then the reciprocal will be, I should have written here, 1 over 100, then the reciprocal will be 100, a very, very high number. So we say it's approaching infinitely large value. So that is the concept of vertical asymptote. On the other hand, if I take a number on this side which is very large, 100, then y value will be, or f of x will be 1 over 100, right? Which is 0. So use two places, right? 0, 1, which is extremely small. So it is approaching 0. Do you see that? So that is called the horizontal asymptote. So in this particular function, we have horizontal asymptote, which is y equals to 0, and we also have a vertical asymptote, whose equation is x equals to 0, the y-axis, right? So this y-axis is an asymptote, x-axis is also an asymptote. So for this function, we can write that the domain of this function is x belongs to real numbers, where x is not equal to 0, and the range for this function is y belongs to real numbers, where y is not equal to 0. Perfect. So that is the domain and range of 1 over x. Now the examples which I am going to take will be transformation of these functions, correct? So let's take few examples now which are transformation of 1 over x. So let me begin by saying g of x is equals to 1 over x plus 2. Then we have h of x is equals to minus 1 over x minus 5, let us say, right? In that case, we can sketch a transformed function and write down its domain and range. Now, if you have with this kind of a transformation, then as you can see, the range will not change, but the domain will change. G of x, x plus 2, that means x cannot be equal to minus 2. So in this particular function, denominator cannot be 0, right? So here denominator cannot be 0, so x is not equal to 0, right? So in this case, we have shifted the denominator 2 units to the left, so minus 2. So here, as you can see, range will remain as y belongs to real numbers. However, the domain will change. So in this case, the domain is, let me write in different form, minus infinity to minus 2 union minus 2 to infinity, right? As far as the range is concerned, it will be from minus infinity to 0 and then from 0 to plus infinity, right? The function as such could be sketched. So the same function shifted slightly could be sketched kind of like this. Is that okay? So that is how the function is going to look. If you use this kind of a transformation, in that case, minus indicates reflection and x equals to minus x minus 5 indicates a vertical asymptote at 5 plus 5, right? So reflection minus means this top part comes underneath, right? So what we have here is a function which is going to look like this. Do you see that? So that is how we are going to have the function. As you can see, range will not change, but the domain will. So for this function, domain of this function, h of x we are talking about, will be x belongs to real numbers where x is not equal to 5, which makes the denominator 0, right? And the range in this case will be y belongs to real numbers where y is not equal to 0. You should remember that range changes if I have an equation which is, let's say, m of x equals to 1 over x plus 3. Let's put here 1 plus 2, for example. Now that plus 2 makes a change. So what really happens now is that the horizontal asymptote moves 2 units up, right? So let me sketch this one now. So the horizontal asymptote moves 2 units up. Vertical asymptote is 3 units left. So the function is now kind of, let me sketch here, kind of like this. Do you see that? It is kind of like this. So you can see that the domain and range both have changed. So in this particular case, domain of the function is x belongs to real numbers, but x is not equal to minus 3, okay, not equals to minus 3. As far as the range is concerned, let me push this page a bit on the front. Y belongs to real numbers, but y is not equal to plus 2. Y is not equal to plus 2. That becomes the horizontal asymptote. I hope this concept is clear. So for any reciprocal function, we could write its domain and range by using the transformations. Remember, denominator cannot be 0, right? So equating denominator to 0 gives us restriction on domain, right? So that is how reciprocal functions are, and for all the reciprocal functions, y is not equal to 0, since that value will not be achieved unless and until there is a vertical transformation, as we saw in this particular case. Do you see that? So most of the time, if we do not have this vertical translation, then y is not equal to 0 will be the range. But if this transformation is there, then that value cannot be achieved. I'm Anil Kumar, and I hope that helps. So in this series, we have taken up all these functions one by one and considered their domain and range after transformation, right? I hope it helps. Thank you, and all the best.